NCERT 12th Physics. We have a exercise problem 211. So before dealing with this problem, we should know some basics about charging and discharging of the capacitor. Okay. Suppose this is a DC source. You have R and C. Okay. Now the switch is connected here. That means this is closed and this is open. So the DC voltage tries to charge the capacitance. And the voltage across the capacitance is given by V, this voltage V into 1 minus e power minus t by RC. RC value we know. T is the time. Okay. Time required to charge a capacitor. At any instant of time also we can find the voltage across the capacitor. So this is the equation. Next, case 2. Case 2 is this switch, initially it was here, but later on it was connected like this. That means the source is disconnected. This is disconnected. Now the charged capacitor, what it will do now, it tries to discharge through resistance, and the equation is given by the voltage across the capacitor is V into E minus T by RC. This is the equation. So first we must know, when the switch is connected here, it is voltage across the capacitor is V into 1 minus e power minus t by RC. Okay. Now if you carefully see, all the problems in the book, plus 2 NCERT book, they have not included resistance. Okay. Suppose, so that means if this R value is 0 means you are just short circuiting. If that value is 0, this denominator term here, R value is 0. 0 into C is 0. Anything T divided by 0 is infinity. E power minus infinity is 0 because it's an exponential decay curve. At infinity it will be 0. That means voltage across the capacitor is equal to V, the source voltage. So what's the important point here? If this R value is 0 or just short circuited, within no time, the entire voltage will be across the capacitance. This is the first important point you have to remember. If you don't have any resistance. If you have some resistance, then the charging time depends on the time constant. That is, RC is called the time constant tau. Coming to the second case is we are connecting the switch here. That means if you don't have a resistance, initially it has charged the full voltage. Okay. That means if you give 200 means here it will be 200 within no time. In case if you have a resistance, still you can reach the 200 voltage, but it takes time. That time depends on RC value. Okay. Now in this case, whatever voltage across the capacitor tries to discharge through resistance, and the discharging equation is given by voltage across the capacitor during discharge phase is equal to V into e power minus t by RC. Once again you just see the discharging phase. If this R is equal to 0, that means if you don't have any R means it's just a short circuit. So if R is 0, this denominator is 0. Anything by 0 is infinity. E power minus infinity is 0. I told you exponentially decaying curve. Only at infinity it will be 0. Okay. So the R is 0. Anything divided by 0 is infinity. E power minus infinity is 0. V into this is 0. That means within no time, whatever the charge held by the capacitor has to discharge. That's why we see a huge spark when we short a capacitor using a wire, because wire resistance is almost negligible. Okay, that's the concept. So what's the concept you have to remember now? When you have no resistance, the capacitor voltage is nothing but the source voltage. This is the important point. During discharge phase, when there is no resistance, within no time the entire charge gets discharged. Okay, for a smooth discharge we have to include resistance in series. That's the point. Okay, now we will see the exercise problem. A 600 picofarad capacitor is charged by a 200 volt supply. It is then disconnected from the supply. Okay, initially it is being connected. That means this is the diagram. 200 volts. Okay, this switch is open, this switch is closed. Okay, so this circuit is open now. That means you have a capacitance here, 600 picofarad. This 200 volts just gets across this 600 picofarad capacitor. That's what I have drawn here. And this is happens within no time. Okay, when you connect to your DC source without any resistance, this 200 volts going to appear here. Okay, now energy for this case is half CV square. Half C is 600 picofarad into 200. This is the voltage. It is going to appear across this capacitor, 200 square. So this is 200 into 200. Okay. 3 2s are 6. 3 2s are 6. 6 2s are 12. 12 pico, and you have 2 4 6. So it will become 12 microjoules. Okay. That is first portion of the answer. Next, it is then disconnected from the supply and is connected to the another uncharged 60 picofarad capacitor. That means this is disconnected, this switch is disconnected, and this switch is connected. That means you have a 200 volts supply across the capacitor, and the capacitance value itself is 600 picofarad, and you are connecting an externally 600 picofarad. That means these two capacitance comes in series. Okay, that means I am redrawing the same diagram here because this is open circuit, you are disconnected. So this is open circuit, you need not worry about that. So this is 200 volts, 600 picofarad, 600 picofarad, both are in series. What is the effective value? 600 into 600 by 600 plus 600. That means since you have the same value, one of the capacitance divided by 2. That is, the total capacitance here is 300 picofarad because both are in series. Now energy is equal to half CV squared. Half C is 300 pico and voltage is 200. That is 200 into 200. Now same thing happens. Okay. Now this 2, 1, 3 2s are 6, 2 zeros, 2 zeros, 2 zeros. Here is pico is 10 power minus 12. So you will get 10 power minus 6. So 6 microjoules. So when the switch is connected here and this is open, it is having an energy of 12 microjoules. Later on, this switch is open and it is close to this switch. 600 picofarad is connected. It starts discharging. So that time the energy is equal to half CV squared, and the equivalent capacitance is 3 picofarad. In that case, energy is equal to 6 microjoules. So initially we were having 12 microjoules. Now we are having only 6 microjoules. So 12 minus 6 is 6 microjoules. So how much electrostatic energy is lost in the process? We have lost 6 microjoules in this process. So that's all about this question. This question is important just because we have introduced what is charging across a capacitor and discharging across a capacitor, and what is the importance of R. So in most of in chapter 2, most of the questions are without R. So if you don't see R, means within no time, once capacitor gets connected to the voltage, immediately it is charged. The voltage across the capacitor is equal to V, the applied voltage. Okay. So and also I gave you one caution during discharge phase. For smooth discharge, you must include a resistance. If you don't include a resistance, a charged capacitor, if you short with the wires roughly 0, then infinite current will flow and the capacitor may get spoiled. So don't try short circuiting a capacitor directly with a piece of wire. Use always a very high resistance value and discharge the value slowly. Discharge the charge slowly. Thank you for your attention. Thank you. Nandri.